It's quite an honor to be here with you today to share our perspectives on something that we call disruptive computing and networks at Boeing, and how we think that's going to be key in transforming aerospace, and the connection, because AI is a huge piece of that transformation, how that all plays together. So if I just take a step back for a minute and think about Boeing and what we're about, our mission statement there: connect, protect, explore, and inspire the world. Now, sometimes when I read that, I think, boy, that's a little over the top. Do we really do that? Then I look down at some of these pictures of just some of the programs and systems that we've been involved with. We don't do any of this alone, but we're key, and it really does make me think that mission statement is what we're all about. Going back to the early days of flight, to developing a whole new air industry, to providing the country with amazing air firepower, to going in to explore space with the Mercury program, the Apollo program, the space shuttle, the space station, to really turning space into a valuable asset in terms of both for the warfighter and for commercial applications, things like GPS systems. There's a trend in there, and that is that artificial intelligence is playing a bigger role in the systems that we develop. And today, we have fully autonomous vehicles that go into space and return. Our newest product is a MQ-25 in the lower right there, refueling a tanker to extend the fighting force of our Naval Air Force. It's really undeniable that AI is going to play a big role going forward. It'll be in every product that we make, every system. And in fact, it'll help us get the leverage of networking these systems together, where you can get a multiplicative effect when you do that. Now, it takes a lot of knowledge and insight to operate in this world that's becoming very complex with these kind of products. That's something that Boeing brings to the table. We also have an enormous amount of data from years and years of building, manufacturing, testing, designing products, operating them, servicing them. And that data, as we just heard, is very valuable in terms of AI systems. In addition to that, to really unlock AI and apply it in the applications that we're interested in, we also need what we think is overwhelming computing firepower. And to that, our company stood up a new organization last year called Disruptive Computing and Networks, with 3 primary focus areas. The first being high-performance computing, which is something that, quite frankly, Boeing has used for decades. We use this for extensive modeling of our products early on in the design phase to improve aerodynamics, structural efficiency, acoustic, noise mitigation, all kinds of very intensive efforts. As our products get more complex, more integrated, you're going to see a tremendous need for more and more of that. And also, as we rely on simulation more and use simulation to create data to feed into AI systems and training, you're going to see that go up a lot more as well. In the center is something that we call neuromorphic computing, or another way to think about this is brain-inspired computing. And this is where we're really thinking now out on the very edge, Internet of Things, in our products. And what's different about this is a very different approach to computing, both a hardware and software approach. And there's a couple key things that really interest us here. One, we need very power-efficient, low size, weight, and power solutions for all kinds of sensing aspects and AI aspects in our products. The brain, as we all know, is an amazing processor. Now, it's not great at everything, but it's phenomenal at certain things. In particular, it's very good at pattern recognition. Okay? But maybe more importantly, the brain is extremely energy efficient. The average brain takes about 10 watts to power. Now, some days I think I'm operating on more like 5 or 6. And so this is a hardware approach and a software approach to try to leverage that architecture to figure out how to use that. Now, maybe even more importantly is the ability to be able to come into a situation that you haven't experienced and be able to handle it safely. That's something that is very difficult in today's world, right? The corner cases and having enough data. While we do have a lot of data in aerospace, we don't have enough, okay? In fact, it's not clear you'll ever have enough of all the corner cases that you can run into. So that's something I think is very powerful with neuromorphic computing. And then finally on the far right are quantum technologies. And by that, we really mean quantum networking, quantum sensing, and quantum computing. And there's an enormous opportunity there to take advantage of that technology, which will probably take a decade or two to develop. So let me just talk quickly to an application. On the left is the airspace around O'Hare today, Chicago, where our corporate headquarters is. What happens when it looks more like the right side? And I think your initial reaction is, oh God, no, it's already hard enough to get into Chicago and get out and get downtown. But no, to have it be what it is on the right and have it be a very positive thing, something that where you can get from your destination that you're at to where you want to go much quicker, much safer, and even less costly. Now, to do that, we think about that today. In fact, we have a whole organization stood up that's focused in this area, Next. And it's one where we are architecting and thinking about the systems, the designs that will be required to do this. And it's one thing to just prototype a little UAV and say, hey, I've got the solution. It's another thing to have an entirely thought-out system that's safe, reliable, and can handle all the things that will happen. Now, there's a lot of challenges with this. It's going to require all kinds of new development, new propulsion systems and battery storage systems, new electronic navigation systems. It's not an easy thing to take on, but that's what we love to do at Boeing. And we think about these disruptive computing and network capabilities and what that can do with AI is a way to address a lot of this. So first is just the design of new products. As I mentioned, high-performance computing is going to be essential to designing in a shorter time span new products and having them tested out and fully simulated long before we ever build the first one, and ultimately have that lead into safe certification. In the area of the product itself, neuromorphic computing is something that we think will give us this very low power, size, weight, and power computing and sensing, potentially. It'll give us this ability to adapt for control and safety when you come up against that situation that you haven't trained on exactly. How will your system respond? And it'll give us the ability to really enhance our communication through some of the signal extraction capabilities that it has to extract signals out of the noise. And then finally, in the quantum area, maybe the most profound underlying thing we think it's going to provide in this industry is the opportunity for really provably secure communication networks. It's provably secure based on the laws of physics. If you're hacked, your communication falls out of a quantum state, and you know it immediately. Additionally, if you take a quantum network and you now start to put some quantum sensors on it, and these can be various things, gravitometers, magnetometers, optical clocks, you can start to do some very interesting things that we think might enable us to operate through a fully GPS-denied environment, something very critical to our warfighters. And if you think about quantum computers, it may give us the ability to re-optimize networks in real time. There is, today, if you think about just today's air traffic system, actually just take one airline, they are not able to fully optimize their network. They come up with a plan, and then the day begins. And if there's a unexpected thunder shower or a pilot doesn't show up that day, their network, they have to try to figure out what's the right call. With quantum computing, we think that will give us the opportunity to fully optimize the total system and ultimately be able to optimize in real time. A huge amount of value is tied up in that. The company is serious about this. making the investments in several locations across the US and as well as the UK and Australia. By the end of next year, we'll have over 20,000 square feet of lab space and office space dedicated to researching these technologies and thinking about how to apply them to systems. Additionally, we know we don't do anything alone. It's all about your network and your partners, and we have some phenomenal partners in this. HRL Laboratories is a place where we do very cutting-edge research. It's where we're actually developing neuromorphic chip technology and experimenting with it. Spectra Labs, where we do a foundry for semiconductor processing. We have a research group that's got 4,000 people across the company, very skilled in bringing technology in and maturing it. And we have Boeing Horizon X, who you've heard the leader of that speak here before, an organization that connects us in to the startup community. And in fact, is the reason we're here today and forming the connection with Spark Cognition. And then later forming a JV to create SkyGrid to go after this problem that I talked about earlier. Now back to what I said, so Boeing loves working on the hardest problems. We love understanding what our customers' needs are and trying to help them achieve those needs. We've got an amazing team of world-class talent, folks that are of almost every discipline that know how to bring the system together, which is key. And then we have our partners. And the bottom line is we're trying to think about how do you fill in those boxes, those blue boxes on the right-hand side. What iconic programs are we going to create in the future? I guarantee you AI will play a big role in that, and we believe disruptive computing and networks will as well. And behind all of this, it's the people of Boeing and our partners. So I know it's a little over the top, but please join us to help us change the world. Thank you.